Hi, my friends. Today we're gonna talk about Cramer's rule in order to find the solution to a system of linear equation. Okay, so we're talking about Cramer's rule, and it's used to find the answer to a system of linear equations. So before we proceed, let me define a few things for you. So as you know, a matrix is shown by brackets. It's a representative of numbers between two brackets, and it could be A, B, C, D. Okay, so this is a matrix, and the size of the matrix is the number of rows times the number of columns. So it's a 2 by 2 matrix. In order to find the value of the matrix, we have to define the determinant. The determinant is very similar to the determinant of a matrix, is denoted by line, two parallel lines, goes like this. Okay, and then let's put small d, and then it is used, as I told you, it is used to calculate the system of linear equation. And then the value of the determinant is a unique number, and I'll show you how to calculate it for a 2 by 2 matrix. So a 2 by 2 matrix, as I showed you here, has got two rows and two columns, and the determinant of this 2 by 2 matrix is this one. But how can I find the value? The value of this determinant, right? It's A times D, okay, minus B times C. This is the value of the determinant, and A, B, C, D could be any constant. So let's do a few questions, like a few examples. Let's say if A is 0, 2, 1, -1, let's find the value of this determinant. So that would be 0 times -1, okay, minus, so this one, right, minus the other, that two numbers multiplied would be 2 times 1. So it would be 0 minus 2, which is -2. Okay, so let's do one more. So it could be a radical 2, 5, 6, -1. Okay, and this is how we show it. So A, determinant. Okay, and then if you want to calculate it, we multiply these two numbers, radical 2 multiplied by -1, and then minus or subtract now these two numbers, which is 5 times 6. The final answer would be negative radical 2 -30. Okay, so the value of a determinant doesn't necessarily have to be a real like a whole number or a nice number. It could be any real number. So this is like a recap of the matrices and determinants. Let's use the Cramer rule to find the solution for systems of linear equation. Okay, so once more, we're talking about Cramer's rule to find the answer to systems of linear equation. Let's assume this is my first equation, and this is my second equation. So A, B, C are the constants or coefficients, okay? And the subscript shows the number of, like here, A relates to the first equation. 2 relates, subscript 2 relate to the second row or the second equation, okay? So A, B, C could be any number, or if any of these are missing, then we assume it to be 0. So we use the Cramer rule to find the value for the unknown parameter here, which is x and y. But how do we use this? In order to find the value of x, first we have to calculate determinant of x over determinant d, okay? Then I will define what is dx and d for you. And the y would be determinant of y over d. As you can see, the denominator for both are d, so the same. So if you find the d once, you can use it for the other fraction as well. So let's see how to find the d of x. Okay, so let me show you first how to calculate the d, then I'll show you how to calculate the dx and dy. In order to find the d, you have to make sure, first of all, the equations, your equations, are nicely aligned. What I mean is that the x's are aligned underneath one another, the y the same, and the constant. Then you can define your D matrix, okay, to be the coefficient of x, the coefficients of y. And we start with the first equation. So here, the first equation, the coefficient of x, it's a1. The coefficient of x in the second equation, it's a2. How about y, b1, and b2? This is matrix D. If I want to calculate the determinant, right, that would be a1, b1, a2, b2. Okay? Now, let's see how to find the matrix and then the determinant of dx. Okay? So dx would be, x is your first variable. Okay? So to find the matrix dx, you have to replace the coefficients of x with c1 and c2, then find the determinants of dx. Okay, so what are the coefficients? Like the constant matrix is c1 and c2. This is your constant matrix, okay? So your dx would be constant matrix, and then it would be b1 and b2, right? Let's do the same and find dy, okay? dy, so y is your second variable, right? So if you want to find the dy, here you have to replace the coefficient of y with c1 and c2, which are the constants, and then find the determinant, okay? So let's see. For dy, we have to go, the y should be replaced by the constants, right? And then the first column doesn't change. Okay? So here, let's do a quick recap. In order to find the answer or to solve a system of linear equation with Cramer rules, First, we have to make sure our equations are nicely aligned. Then we have to define the D matrix, dx and dy. Here we only have dx and dy because we only have two unknown variables. So the D matrix would be the coefficients of x would be on the first column, and then the coefficients of y in the second column. And what is your dx? X is your first variable. So this column would be replaced by the constants, which is C1 and C2. And then the Y column doesn't change. Here, for the dy, it would be actually the opposite. So the Y column would be replaced by C1 and C2. The X column doesn't change, A1 and A2. Okay, so this is the theory. Let's do a couple of examples, for practice. And as you can remember, the systems of linear equation could be solved from 2 or 3 different methods, like graphical. It could also be, let's say, Cramer's rule, graphical, or substitution and elimination. But now we are only focusing on the Cramer's, okay? So let me give you an example. The first equation would be 2x plus 3y equals 13. And the second equation would be 3x minus 5y equals -9. Okay, so this is an example, and I want to solve it through Cramer's rule. So first of all, I have to make sure my equations are nicely aligned. Okay, x, y constant, they're nicely aligned. Then I will start with forming the D matrix. Okay, so the D matrix would be x, y, and then I have to put the coefficients. The x would be 2 and then 3. The y would be 3 and -5. So what is the size of the matrix? Number of rows, number of columns, which is 2 by 2. Okay, so remember, this is the matrix and this is the symbol we use. From here, we will define the determinant, which is the unique value of this 2 by 2 matrix, and it's 2, 3, 3 minus 5. Okay, and from here we can find the value of this determinant, which is 2 times -5, okay, minus 3 times 3. Okay, so that would be -10, -9, which is -19. Okay, so that is the value of your D, or the determinant. It's -19. Then we have to find the x. I try to form the determinant. I'll go to the determinant directly instead of defining the matrix and then the determinant. I just skip this step and then define the determinant. So the dx would be, the first column would be replaced by the coefficients or the constants, okay? The constants, which is 13 and -9, okay? 13 and -9, and then 3, -5. So let's calculate it. 13 times -5, -3 times -9. So that would be -65. -27 plus 27 would be -38. Okay, so we have to do a similar thing for determinant of dy. Here, the first column wouldn't be changed, so 2 and 3. But the second column would be replaced by the constant, which is 13 and negative 9. Then I have to calculate the determinant, which is 2 times negative 9, negative 13 times 3, which the final answer would be a negative 57. Okay, so far what we did, we calculated the determinant d, determinant dx, determinant dy, and from here we can simply find the value of x and y. So remember, x would be dx over d, and both are determinants. So dx over d, that would be negative 38 over negative 19, which is 2. Okay, and y would be determinant of y over determinant of d. So the d is negative 19 and dy would be negative 57, which the answer would be 3. So the x is 2, the y is 3. Okay, remember, I always suggest after finding the result or solve for x and y, you can simply go back, substitute, and make sure you got the right answer, because that's from here, just checking your answer would only take like 10 seconds. Okay, so I have to right now, let's say I use one of these equations here and I substitute for x and y and make sure like my answers are correct. So the x, 2 times the x value was 2 plus 3 times y should be equal to 13. Okay, let's see if that's the case. 2 times 2 is 4 plus 3 times 3, 9. 4 plus 9, yeah, 13. So that means my answers, which I found by Cramer's rule, are completely correct, and it satisfies my equation. Okay, so that was the first example. I will do another example for you. You could maybe stop the video, solve it on your own, and then check your answer. So the second equation, the second example, example number 2 would be 2x minus 7y. 2x minus 7y, it's equal to 1. And then 3x plus y, 3x plus y, it's equal to 13. So I have two equations, that is a system of linear equation, and I want to use the Cramer rule, which is used to find the solution of 2 or 3 linear equation. And here I only have 2 linear equations. So first thing first, I have to make sure it's nicely aligned, the coefficients and the constants. Okay, then I go step by step. First thing, I have to define the D matrix. I'll start by defining the D matrix, which is coefficients of x, coefficients of y. Coefficients of x would be 2 and 3. Coefficients of y would be negative 7 and 1. From here, I can define the determinant, which is a unique value for this 2 by 2 matrix. Okay, which would be 2, negative 7, 3, 1. And then let's find the value. So 2 times 1 minus 3 times negative 7. Okay, so the answer would be 23. So the determinant of D is 23. Step 2 would be forming the dx matrix. Okay, dx matrix, remember, because we're talking about the dx, that means the first column, right? The first column should be substituted with the constant, which is 1 and 13. The second column doesn't change. From here, I would form the dx matrix, which is 1, 13, -7, and y. And then now I can find the value of this determinant, which is 1 times 1 minus -7 times 13. So dx would be 92. Okay. Step 3 would be forming dy. Okay. First I form the matrix, then I form the determinant. So here y is the second variable. Okay, so the first column doesn't change, so it would be 2 and 3, but the second column, it would be replaced with the coefficients, which is 1 and constant, which is 1 and 13. Now from here I form the determinant, which is 2, 3, 1, 13. Then I find the value, which would be 2 times 13 minus 1 times 3, and the answer would be 23. So that's step 1, step 2, step 3. And then from here, that would be just a piece of cake, because x, your first variable, would be dx over d, which both of them are determinant, okay, which happens to be 92 over 23, which is 4. And then your y, your second variable, would be again d in the denominator, but here dy, and we calculated these values before, so 23 over 23, which is 1. Perfect. So I found the value for x, I found the value for y, but remember, I always suggest you check your answer. So we're not done yet. We go back to our equation, we just substitute the values we find, and we make sure we are on the right track. So 2 times x, 2 times, we found the value of x to be 4, minus 7 times the y, we found the value of y to be 1, should be equal to 1. Okay, let's check. 2 times 4, it's 8, minus 7. Yes, that's equal to 1. So that means our final answer, 4 and 1, x as 4 and y as 1, are completely correct. Perfect. So in this video, you learned how to use the Cramer rule to find the answer for a system of linear equation. In these two examples, they were 2 linear equations. In the next video, I will show you how to use the same rule, Cramer rule, to find the answer to linear equation, to system of linear equation with 3 equations and 3 variables. Because if you see from previous examples, or even this example here, you only had 2 equations and 2 variables. See, even in the previous one, you had 2 equations and 2 variables, right? And this is very simple and easy to calculate. The system of linear equations with 3 equations and 3 variables, it's also very easy, but it has more calculations. So you should be really careful how you calculate a 3 by 3 determinant, and don't forget to check your answers. See you in the next video. Please don't forget to subscribe to my channel and like my videos. Thank you.